Hi students, today we will discuss the second part of the DCN. First part we have seen the first unit regarding the protocol hierarchies. From that we will continue this. Okay. Myself P. Rajesh, Assistant Professor, Department of ECE, B. Viraju Institute of Technology, Narsapur. Okay. Today we will discuss the course name as Data Communications Network. Okay. Second part. Okay. These are the various course objectives and prerequisites we have seen in the first class. And then the course outcomes, and then the unit 1, what are the different types of topics what I have completed in the last class. Okay, classifications of computer networks we have completed, network architecture, network applications, LAN, okay, LAN network, computer network topologies we have completed. And then we will see today protocol layering, OSI model. Okay, layering, what is the importance of layering of protocols, and the OSI model we will see today. Okay, these are the protocol hierarchies what we have seen in the last class. Just we will revise it. A protocol is a set of rules and regulations for data communications. Okay, and then protocol hierarchies, different large number of hardwares and different types of softwares we are going to be integrated in a single layering. For each layer, we are having different hardware networking and different softwares. Different protocol sections will be there. Okay, and the key elements of protocol: syntax, semantic, and timing. Okay, the way of format we are going to write the program, and the way of sending the message, and what time it should be sent, and what time it should be received, and what is the speed of the time. Everything will be required from this. Okay, then we'll see the layering architecture. Layering architecture. Suppose we'll see why we require this layering. Okay, suppose if you're having a network, for this we are having layer 1, layer 2, layer 3, layer 4, like that we are having layer 1, layer 1, layer 1, layer 2, layer 3, like that, layer n minus 1, till that layer n minus 1, layer n, till n, 1 to n number of layers that can be used here. For each layer, we are having the different set of rules and regulations for each layer. Okay, for second layer, another different types of rules and regulations. Third layer, like that up to nth layer, we are having the different types of rules and regulations to do some work, some actions for some data transferring. Okay, for that, layer 1 need to be interacted with layer 2, layer 2 be interacted with layer 3. Like that, each layer will be interacted one by one. Okay, layer 1 be interacting to layer 2, layer 2 will be layer 3, layer 3 will be layer 4, up to n. They are interacting each other. Okay, that means they are sharing the information within the loop, or they can provide and access the services from the other layers. Okay, for layer 1, there is having some boundaries. Without that boundary, they cannot access, they cannot do some work. Within the boundary only they need to do. The rules or the set of protocols which are access are given to that particular layer. That work should be done only in that particular layer itself. Like that, we are having the n number of layers. Okay, all these layers will combine to form one application purpose or one section of work. If you want to modify any rules and regulations in that particular layer, we can go to that particular layer protocoling and we can modify that. This is the main motto of the layering created for different level of abstraction. Layering created for different layer of abstraction is needed. Okay, this is the layering architecture. With this layering architecture, they have designed some networking types. Networking, just like OSI model, TCP/IP model, all this came from networking architecture. That is layering architecture they have accessed. Okay, that we will see what is meant by a OSI model. Very important topic and a very important large question also. Can go through that in deeply. Okay, OSI model. What is meant by OSI? OSI, Open System Interconnection. Open System Interconnection. Open System Interconnection. Okay, this is the meaning of OSI model abbreviation. And then coming to the how it is framed and who it is framed, everything will be so. Okay, this is one of the proposed model. Okay, it is one of the proposed model of which is proposed in the it may be a 1983. Okay, 1983 it is proposed one OSI model. Who it is proposed means International Standard Organization is there. Okay, ISO, International Standard Organization. They have given some suggestions to the open OSI model in 1983. Okay, from that it covers all the accepts. Okay, it checks all the different countries, different rules, different countries, different set of rules and different set of protocols, different systems, different OSs. All they have taken into one consideration, and they have designed an open source, that is common platform for every systems which are going to be interconnected within the world. Okay, that is OSI model. Okay, it is not a protocol. Okay, OSI model is not a protocol. It is a layering model. It describes each layer and its functionality. Okay, it is not telling about the protocols or any other. It just OSI model tells about the functionality of the each layer which is present in the OSI model. Okay, the concept is clear. We will discuss each layer and its functionality, how it will be and what is its functionality of the OSI model. We will see one by one. Okay, now I will draw that circuit diagram how it will be. Okay, total for this OSI model we are having 7 layers. 7 layers. Okay, we'll see first one. First layer is physical layer. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, these are the 7 layers which are present in the OSI model. We'll go in depth how it will be, what are the different types of protocols, how it will be linked. Okay, this is the host A. Like that we are having another side, host B. Okay, physical layer, data link layer, okay, network layer, transport layer, session layer, presentation layer, okay, application layer. Like that we are having the same layers which will be reflected here at the other end. For application to application layer, presentation layer, from presentation to presentation layer, session to session layer, transport to transport, network to network, data link layer to data link layer, physical layer. At the host side, okay, application layer which is present, and the other host side, okay, host B side, application layer which is present, both should be matched. Both should be of equal application rules, and set of rules will be same. Then only it can understand. Okay. For this, the data which is present in the application layer can call it as APDU. Application Protocol Data Unit. The data which is present in the application layer is APDU. The data which is present in the presentation layer is PPDU. Protocol, okay, the presentation protocol data unit. Session layer, session protocol data unit. The data unit which is present in the session layer is session protocol data unit. Transport layer, TPDU. Okay, transport protocol data unit. Whereas coming to the network layer, this is different. Okay, coming to the physical layer, having the bits. Data link layer, we are having it as a frame. Here we can call it as a, okay, packet. Okay, frame, bits, packets. Only for these three we are having the different layers. Okay, this is the application protocol. Application protocol, same source. For this and here, same set of rules will be there. For presentation protocol. Both should be match. For session layer, here session layer, same session protocol, that should be match. For transport protocol, that should be match. Coming to the network layer and data link layer and physical layer, we are having the intermediate other routers will be there. For network layer, intermediate network layer devices will be there. Network layer devices. For this data link layer, we are having mediators, data link layers, DL, other devices will be there in the mediators. Okay, and physical layer, we are having the physical layer, the mediator. Okay, all this will be the intermediate nodes, or it may be called it as routers, which are present in the networking. Okay, routers. And then from physical media to data, we are going to send to the another side with the help of the other medium. Okay, here in the physical layer, we'll call it as a bits. It may be in the form of 0, 1, 1, 0, 1, 0, some data format that can be transmitted as a signal format. Okay, signal. Okay, signal. This signal should be received at the receiver side. Received at the receiver side. Okay, host A will be the sender, host B will be the receiver. Okay, these are the main basics we need to know about the OSI model. Okay, in OSI model, we are having the 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And then other side also the same 7 layers should be there. From here top to bottom, from here bottom to top. Okay, data will transfer from here and then it transfers to the transmission media and then it receives to the receiver side. Okay, we will see the one by one from physical layer to application layer. What is the functionality of each layer? We will see one by one. Okay, next, first coming to the physical medium. Okay, physical medium, how the data will be there in the physical medium. Okay, physical layer. Okay, this is also physical layer. Physical layer. The data which is present in the physical layer is as follows. How it will be? 1 0 1 0 1 1 1 0 1 1 1. Like that, some raw bits will be there. At the receiver side also, same raw bits that will be received here. 1 0 1 0 triple 1 0 0 0. Same data should be there. Okay, this can be transferred to this with the help of the transmission media as an intermediate. Okay, intermediate. This intermediate will be in the form of signals 1 0 1 0 1. Okay, 1 1 0, like that the signal will be there. Okay, this will be received at the receiver. From where it is receiving that? From layer 3. Above layer is data link layer. Data link layer. We can call it as layer 6. Okay, layer 6. Layer 2. Layer 2. We will check layer physical 0 layer will be the 1, 2, 3, 4, 5, like that. We will go in the upward direction. Here this is physical layer. Here at the receiver side is also a first layer. So it sends the message to whom? To the data link layer. DL, data link layer, which is of layer 2. Okay, L2. Here it sends message. Okay, that means physical layer will provide services to the data link layer. Physical layer will provide services to the data link layer. Whereas at the other side, data link layer will access the services from the physical layer. Okay, two-way communications. One is providing services, one is accessing services. Okay, this is related to the physical layer. Okay, first one, physical layer. We will see one by one point. We will discuss regarding this physical layer. What are the different types of functionalities will be there here? Okay, here in the physical layer, the data will be in the form of raw bits. Data will be in the form of raw bits. That may be in the form of zeros and ones. Zeros and ones format the data will be there. And then second point is the services for this data physical layer. Okay. Here the data is treated as bits, that is zeros and ones format. And then how the link will be established in between the two or more devices. Physical link between devices. How the link will be created, either it may be a simplex or full duplex or half duplex. The link will be created. And then, or either it may be in the form of a tree topology, star topology, ring topology, like that, different formats will be there. And then how the data flow, either in the only one direction or two-way or parallelly, both direction. That we need to decide here. This is the third point. And then coming to the fourth point, topology is required. Topology required. Okay, topology required. And the last point will be the bandwidth, or we can come under the cable length. Length of the cable is short means very quick. Length of the cable is long means it takes some time to transfer information. Like that, we are having some few features will be there. Okay, related to the physical layer, first layer, that is physical layer. Physical layer, we will see that. Okay, raw bits will be there. The data which is present in the physical layer will be in the form of raw bits. Either it may be a zeros and ones format. And then the physical link, how the link will be created in between the devices, that will be taken care by here. And the data flows, either to be a simplex mode or half duplex or full duplex mode. And the topology is required. Which type of topology is required to form, okay, to design. And then the bandwidth and the length of the cable, everything will taken care by the physical layer. This is the regarding to the physical layer of the OSI model. Physical layer of the OSI model. And then we will see the next one, data link layer. The diagram will be the same, but I will add one more here. Okay, one more I will add. The same will be that here also. 10110. Okay, data will be there. From here, it follows with the data link layer. This is the data link layer. This is of layer 2. Okay, this is also data link layer. Here also the same format will be there. Okay, how? What will be added in it? Here, this is the data. This is the trailer. Okay, T2 and H2. And this is the data where we are going to send 101011110011. Okay, this data. This is the physical layer, layer 1, and this is the data link layer, and this is the physical layer 1, and this is the data link layer. Here also the same, T2 and H2, and between this data 1010111100. Okay, like that data will be there. This is the data link layer 2. What will happen in this data link? What is the functions of this layer? Here, from where it is coming the data? From above layer. From above layer the data is coming. The above layer is network layer. Network layer. Here it sends to the network layer. This is layer of layer number 3, L3. L3. Here the same concepts. The same concept. We will see that data link layer, how its functionality and what is meant by H2 and T2. Okay, here we have decided H2 and L2. H2 and T2. T means 2 means from second layer, it is second layer. So we have decided as 2 numbering. And H is header, T is the trailer. Okay, starting and ending point. Related to the H2, which is having the source and destination address. Source and destination address. source and destination address will be present in the data link layer which is added here. Okay, we will see one example how this will be formed and how this will be act. One example we will see here. There is a one system A, B, C and D. Okay, these are the four systems we are having in the, okay, which is connected with a bus. Each system will have some address 10, 20, 30, 50. Some address will be there. In the data link layer, how the data link layer will looks like. Okay, T2 data, and here we are having H2. In this place we are having the 10, 50. That means 10 is the source address, 50 is the destination address. This packet will move from 10 to 50. Okay, this is a simple example regarding the data link layer. What is added in the data link layer? Okay, in the data link layer, it adds the address of the next protocol. Okay, next destination or next node. Next node address will be added in the, okay, H2 header files. Tailor will be the end of that particular data. The data will be same either in the physical layer or data link layer, network layer. The data will be same. Only change is the H2 is added, T2 is added in the data link layer. Addressing will take place. Source address and destination addressing will take place. And also the few control access will be there here. That is, first one will be the main objective of this data link layer is node to node delivery. Node to node delivery will be there. Node to node delivery will be there. And then second point will be the, okay, addressing. And third point, access control. Access control. And fourth one will be the flow control. Fifth one, error handling. Fifth one. And the next one will be the synchronization. Okay, error detection and handling, synchronization will be the few services or few functions of the data link layer. Okay, node to node delivery, that will be taken care by the data link layer, and addressing also will be taken care by the data link layer. Access control. Okay, the channel will be controlled by the data link layer. Once it is accessed that particular channel, the total channel will be controlled by the data link layer. And the flow control is also the how much the amount of data to be transmitted in that particular channel. That will also will be handled by the data link. Okay, data link layer. And then the flow control, and then the error handling. Okay, error control and error detection. Thus, all these techniques will be taken care by the data link layer. Okay, and the synchronization. Okay, which will be in the at least one receiver should be there for synchronization. Okay, this is related to the data link layer and the physical layer. And then coming to the next layer. Next layer will be the network layer. We'll see in the network layer what the functionality of the network layer. Okay, that we will see. Same as, say the diagram will repeat, physical layer, data link layer, and above will be the network layer. Okay, for this network layer we will discuss here. In the network layer, okay, in the network layer, which is the layer number as L3. The below will be the L2. Above will be the L4. Same as here also. L3, L4, L2. Okay, this is the sender side and this is the receiver side. Okay, here what will happen? Here in the same format, here H3 will be added. H3 will be added, header 3, and remaining will be the data. Okay, remaining will be the data. Here, data with H3 will be called it as packet. Here, in the previous data link layer, it can be called it as a frame. Here, it is called it as a packet. Okay, packet. What it contains in the network layer? What is the functionality of the network layer? Here, the main functionality of this network layer is switching. Switching techniques. Okay, switching and routing. These are the two main functions of the network layer. Switching, routing, and also the congestion control. Congestion control. These are the three main objectives or main functionalities of the data network layer. Okay, switching, routing, and congestion control. We'll see one example for this, how it can access. Okay. Okay, I am deleting this and I will draw another diagram. With that, we will see one example how the network layer will access the networking and routing and switching, how it takes place. That we will see here. Okay, suppose we are having some systems B, C, D. Okay, which are connected to a particular bus. Okay, here we are having one router. From this router, it is connected to different routers and different networks will be there in between. Here one ring will be there. For this ring, C, D, E, F, G. From the this is a ring network, and here from another router will be there. From this here, it comes to the another bus. This bus also we are having the another G, H, I, J, K. Like that we are having the different pieces will be there. For each system there is some IP address. Okay, we will see some IP address, different IP address will be there. The main, we are talking about the network layer. Data. H3 means from A to different. What is the receiver? Sender will be the A. Who will be the receiver? That we need to write. Okay. From A to K I need to transfer. So A to K. This is the H3. H3. A and K. A and K will be the source address, K will be the destination. And in the next data link layer, we have added H2 will be there. In that, source address and destination address will be there. Suppose here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 15, 66, 77, 88, 99, 68. Like that, different addressing will be there. So, for example, I have given for first in this box, the address will be 10, comma, where it need to go? Need to go K. But K address is not there in the particular area network. So, you need to transfer through the router. For router, we are giving an IP address as 50. So, 10, comma 50. It transfers from A to router. Here, the frame will be changed. Data A, comma K will be the same. Here, the source and destination address may be changed. Okay, from where to where they need to go. Okay, from 50 to 50 it reached. From 60 to where you need to go. Next router, shortest path. If you go like this, it is a distance more. If you go like this, this is the shortest distance. So 60 to 15. 60, comma 15. 60, comma 15. Shortest distance it travels. From here to here, this packet has arrived here. Okay, a packet arrived, then it changed the next address also. Data A, comma K will be the common. 60, 15 is changed, replaced with 66 and 68. 66, comma 68. Okay, this is the last routing technique, 68. From 66 to, it travels to the bus and reaches to the destination. This is the way how the network layer will switching techniques and routing techniques will place. Okay, switching from one network to another network, routing shortest distance path. Okay, from this network to is switching to another network, switching takes place, and from here to here and here to here, routing technique will be there, shortest path or any other routing technique. Okay, from here to here another more switching techniques place. So in the network layer, switching, routing and synchronization will plays an important role. That is the main function of the network layer. And then coming to the next layer, okay, transport layer. In the transport layer, we are having, this is the transport layer, okay, transport layer. In this transport layer, the data which is coming from above layer, session layer, okay, this is a session layer. It is coming data to the transport layer. Okay, then below it will be the network layer. Okay, here in the network layer and data layer, H2 and H3 is added, whereas on the transport layer also some other header files will be added. Okay, here the data received from session layer while coming to the transport layer, this transport layer will the received data will be provided, data will be made into some few pieces, few parts. Okay, one single data which is coming from the session layer will be made into few pieces of data. Okay, like that few pieces will be made, for each piece having some address. Okay, physical layer, network data link layer, network layer, transport layer. Transport layer will be the fourth layer, so H4 will be added. Same as this process will be repeated at the receiver side also. Okay, what are the main functions of this? The first function is the received data is broken into few pieces to comfort for transmission of data. Okay, comfort for transmission for transporting the data. Okay, here we will having the connection oriented and connectionless orientation will be there. Okay, connection oriented services and connectionless services will be there, and this process we can call it as segmentation. The received data is broken into some small pieces which is known as segmentation. This is easy to transport whether in the connection oriented or connectionless oriented transmission. Okay, this is regarding the few functionalities of the transport layer. And then coming to the next layer, which will be the session layer. Okay, session layer, how it will be, what are the few functions of the session layer, that we will see here. Okay, session layer. Session means we can call it as session establishment and disconnect, as well as the token management and synchronization. Everything will taken care by the session layer. In the session layer, just we can draw this diagram. Okay, this will be the synchronization, SYN, synchronization will be there. Why we require synchronization, we will see. The first main functions of the session layer is session establishment, and session termination. How much times we need to stay connect to that particular session, everything will taken care by the session layer. Synchronization, one more is synchronization. How the synchronization will take place? For example, 100 pages will be there. At a time, we cannot transfer the 100 pages. If you transfer the 100 pages at a time, if the network is disconnected, what should happen? Again, we need to transfer all the information from 1 to 100 pages. If you made few pieces and you can accept the synchronization process, then 10 pages, second 20 pages, third 30 pages, 40 pages, like that. Okay, 1 to 10, 11 to 20, 21 to 30, 40, 31 to 40, like that. We will divide it few parts. Each will be synchronized at the receiver. Okay, if you use this process, if the network is disconnected, the network is uploaded up to 20, then we can continue with 21. We cannot again, we need to transfer the 1 to 20 again. It is not necessary if you use this process. Okay, time is not wasted and the speed will increase. Okay, bandwidth also we are going to save with this process. Okay, this is regarding the session layer. And the next layer is the presentation layer. Presentation layer. Presentation layer. Presentation layer will be the sixth layer. Okay, L6. Okay, L6, layer 6, presentation layer. What this presentation layer will do? This presentation layer will do the main features is encoding, encryption, decryption, okay, compression of data. Everything will be taken care by the presentation layer. Okay, encoding, encryption, okay, compression of data. Okay, everything will be done by under the presentation layer. Okay, encoding will be done by the sender side and receiver side. Decoding will be done. Encryption will be done by the sender side and decryption will be done by the receiver side. Okay, compression will be done at the sender side and receiver side. Decompression will be done. Okay, the size of the data packet or the memory size will be decreased by compressing. Easy to transfer. Wastage of data will be reduced. Okay, everything will be taken care by the presentation layer. And the last layer will be the application layer. That will be the seventh layer. Application layer. What will do the application layer? Okay, application layer is the user interaction, where you can use some browsers or some pages or WhatsApp or Facebook, everything that will be user end services. Okay, if you open one applications, that data will be sent through the physical layer, presentation layer, session layer. Everything will be taken care by the under these layers only. Okay, few examples for this application is HTTP, Hypertext Transfer Protocol. HTTP page will be opened. The page will be responded to the internet. Okay, everything will be taken care by the application layer. Okay, user end applications. Okay, this is regarding to the OSI model, OSI reference model. And also we are having the another model, that is TCP/IP reference model. In that TCP/IP reference model, we have reduced that 7 layers into 5 layers. Okay, or 4 layers. Top 3 layers, application layer, presentation layer, session layer, these 3 layers are combined into a single layer, that is application layer. And the last 2 layers, physical layer and data link layer, these 2 can be combined to form a network access layer. So that the layers in the OSI model will be reduced to 4 or 5 in the TCP/IP reference model, TCP/IP model. Whereas in the TCP/IP model, we have discussed regarding to the protocols, not to the layering functionalities. That means TCP/IP will discuss regarding the protocol, related to protocols, not to the functionality of the layers. Whereas in the OSI model, we have learned regarding the functionality of the each layers. Okay, this is the main point related to the OSI model and TCP/IP model. In the next class, we will see the last topic which is left in the first unit, that is TCP/IP protocol. Okay, TCP/IP protocol suite, that will be left. With this, the first unit will be completed. In the next session, we will close that the TCP/IP reference model, and then we will go to the unit 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.